Alright guys, so in this video we're going to wrap up a little bit of concavity talk with the topic of inflection points. So the goals within this video are to define inflection points and identify how many inflection points a graph actually has. And what I want to do is I want to look into what does it actually mean to change concavity when we go from the original function to the first derivative and then even to the second derivative of a function as well. So let's think here for a second. Let's say we have a graph that there's our y and our x-axis, and let's say we have a graph that looks something of the nature like this, okay? And so obviously we can see what's happening in this arch right here. We are concave up because all of the tangent lines are above the particular curve. So if this is concave up, this is the graph of f of x, okay? So this is going to be concave up. And think about what's happening, I guess, in all this particular areas. So slope starts to increase, and it starts to increase. Let me put this in green. So slope is increasing, and it's starting to slowly decrease until it actually bottoms out at 0 here, and then all of a sudden it starts to be getting negative. There's a point where it gets negative. And then think about what's happening here. Then as you're kind of going along, you reach a point somewhere right around here in which it's almost like the graph is starting to go back up, and the slopes are still negative, but they're getting closer to 0 once again, so that means they're increasing right there, and they get bigger and bigger until finally the slopes are all going to be positive. And once again, we see here this is going to be concave down. So we got to kind of think to ourselves, what is happening particularly at all of these spots? Well, let's go back to the graph of f prime of x. So in the interval from here to where I made what I will define as an inflection point in a little bit, we see that the slope is actually starting to decrease after it bottoms out here at 0. And so the graph of f prime is really going to look something more like this. So we see that it's pretty strong positive when it starts out, so that's going to be its positive spot up there. And then it starts to go negative and gets just a little bit slower and lower and lower until we hit that inflection point. And then all of a sudden we start to get a little bit steeper and more positive and more positive and more positive until finally we're back on up. And so we see here, this spot is that same inflection point that we'll see up here, okay? And we haven't really defined inflection points yet, but we'll talk about it in just a second. And so if that's the graph of f prime of f, what about f double prime of x in this case? Well, now, this entire way down on f prime, that slope is negative. I hit my inflection point, and then my slope is all going to be positive. So I'm going to take it all negative, so that means my derivative after that is going to be all negative values. So I'll have all negative values until I hit that inflection point, which changes the graph, and now it's all going to be positive in that case. So hopefully from this you can kind of start thinking, well, what is an inflection point? Well, the inflection point itself is what's about to happen when the slope goes from decreasing to increasing, or really when it goes from concave up to concave down. So we can say the inflection point is when the graph goes from concave down to concave up, or from concave up to concave down, or you can think of it when slope increases to where slope decreases, or when slope decreases to where slope will then increase. So think about it for a sec, all right? That point of concavity is really kind of where it changes. So if it will ever ask you, hey, where does or how many inflection points will a graph have? Well, that's the number of times it goes from concave up to concave down, or the number of times that the slope changes of the function. So in this case, if I'm looking at f of x is really going to only have one inflection point right here, because that's where it goes from concave up, and it starts increasing the slope once again, and then starts becoming a concave down function. Okay? So that kind of defines what it is for us. In the next video, we're going to look at a specific example of points of inflection.